Hello, the Math Dog here. This is a trigonometry video. Specifically, it's a trig identity proof video where I'm going to show that the cosine of angles A plus B equals the cosine of A times cosine of B minus sine of A times sine of B. So before tackling this video, I highly recommend that you watch my video where I derive the cosine of A minus B, that's angle A minus angle B, equals cosine A times cosine B plus sine A times sine B. So what we're proving here, we're going to show what the cosine of the sum of two angles is equal to. And we're going to show here, or we showed here, what the cosine of the difference of two angles gives us, which is this. And I recommend watching this because we're going to need this identity or property to do this proof that we're looking at in this video. So let's get started. So first of all, I want to review what is an even function, what is an odd function. So let's look, first of all, talk about even functions. So some characteristics of even functions. So let's say I have a point A, f of A for some function f of x. And then if I reflect that point over the y-axis, which I'm going to call a line of reflection here because it's like a mirror image, I'm going to get negative A f of negative A. Okay, both these, so both A and negative A generate a point that is the same height from the x-axis. Okay, well, we could just keep doing this, and what we get is we get a situation such that the left side of the function matches or is a mirror image of the right side of the function. So if I reflect each point here over the y-axis, I will get the left side being a mirror image of the right side. So what we can say here is that, note that f of A equals f of negative A because they are both the same height from the x-axis. Okay, and when we measure height, of course, we measure perpendiculars. So if a function is even, we will say that f of A equals f of negative A. So in layman's terms, if the left side is a reflection of the right side over the x-axis, this should be the y-axis. The y-axis, the function is even. So once again, if the left side of the function is a reflection of the right side over the y-axis, the function is even. Okay, so now let's talk about odd functions. So if I have a function that looks like this is actually, could be like f of x equals x cubed. This, by the way, could have been like f of x equals x squared. So this is like f of x equals x cubed. If I have a point A, f of A, and then I reflect it over the y-axis, I get this point, negative A, f of negative A. It does not match, though, the original function, which I've put in gold color here. But then if I reflect it over the x-axis, this is the x-axis, y-axis. If I reflect it over the x-axis, I get negative A, negative f of negative A, because this goes from f of negative A to negative f of negative A when I reflect it over the x-axis. Well, that point gets put back on the function f of x. So we will say a function is odd if f of x equals negative f of negative x. So in layman's terms, if I can rotate this function 180 degrees about the origin, which would be right here, and it duplicates itself, we say the function is odd. So here's what I'm talking about. I'm going to demonstrate this algebraically now. So suppose I have f of x equals x squared. This will be, turns out this will be an even function. Here's why. So notice if I take f of negative x, everywhere in this function I replace x with negative x. So I get the negative of x squared, but that's x squared. Therefore, 3 dots there means therefore, f of x equals f of negative x. Thus, f of x equals x squared is even by what we just defined a few moments ago. So now, let's take a look at an odd function. So it turns out f of x equals x cubed is odd, and here's why. So notice that f of negative x here, so I'll start with f of negative x. So everywhere there's an x in f of x, I replace x with negative x, and I cube it, or take it to the third power. Well, negative to the third power, any negative to an odd power is negative, and so a negative to the third power is negative. So this is negative of x cubed. Now notice now if I take negative f of negative x, that becomes the negative of negative x cubed, which in fact a negative makes a positive, so this is x cubed. So notice that the original function and this are the same, so we can conclude that f of x equals negative f of negative x for x cubed. Thus, f of x equals x cubed is odd. Okay? So now let's look at the graphs of sine and cosine. So this is the graph of sine x from negative 2 pi to 2 pi, and it has a minimum of negative 1 and a maximum of 1. So notice if I rotate this function sine x around, and by the way, negative 2 pi would be negative 360 degrees, this would be 360 degrees in degrees. If I rotate this around the origin, let's just take that little piece there. If I rotate this 180 degrees, notice it's going to match itself. That suggests visually that in fact this is an odd function. So sine x is odd. Thus, we know that sine of x equals the negative of sine of negative x. And we're going to need that in a few moments. Okay, now this is the graph of cosine of x from negative 2 pi to 2 pi, or negative 360 degrees to 360 degrees. The minimum, again, is negative 1. The maximum is 1. So notice that the left side is a mirror image of the right side when I reflect it over this line of symmetry, which is the y-axis. So we know, therefore, that cosine x is even. And from what we've discussed earlier a few moments ago, we know therefore that cosine of x has to equal cosine of negative x. And we're going to need this. Okay, so let's continue. Alright, so again, what we're trying to show in this video ultimately is cosine of a plus b is cosine a times cosine b minus sine a times sine b. And as I mentioned at the very beginning of this video, I will need to use the property cosine of a minus b equals cosine a times cosine b plus sine a times sine b. So here's how I'm going to start. So I'm going to write cosine of a plus b. I'm going to rewrite that as cosine of a minus the negative of b. And then I can use this property right here. So this has to then equal cosine of a, and in this case cosine of b is going to be cosine of negative b, because this is again a minus this is negative b, and that's going to be plus sine a times sine of negative b. Okay, well, we just went over this, so cosine of negative b, cosine of negative b is equal to cosine b. So I can make that substitution there. So I have equals cosine of a times cosine of b plus sine a. So now what am I going to do with this? Well, notice that we know from a couple moments ago, we talked about odd functions as well as even. I know that sine of x equals negative sine of negative x. Therefore, in this case I'm using b, so I know sine of b equals negative sine of negative b. Well, if I divide everything by -1, let's put a -1 there. If I divide everything by -1 on both sides, I get sine b, I get negative of sine b is sine of negative b. So I can replace sine of negative b with negative sine b, and that's what I'm going to do over here. So I'm going to make that substitution. So this is negative sine of b. Okay. Okay, so we can simplify this a little more. This would be cosine of a times cosine of b. And then this is going to put that in parentheses now. Cosine a, no, I'm not going to put in parentheses. That's cosine of a times cosine of b. Now that's sine a times negative sine b, so that's going to be minus sine a sine b. And that is what we're trying to prove here. So let's write it down again. So we have cosine, our final conclusion is cosine of a plus b equals the cosine of a times cosine of b minus the sine of a times the sine of b. And that is our final result, which is what we were trying to prove. So this concludes the video. If you found this video informative and you liked it, please give it a thumbs up and consider subscribing to my YouTube channel, The Math Dog. You may share the content of this video with others. Thank you very much for taking the time to watch this video, and have a good day.